All right, dude, we are live. What's up, guys? This is Dem Keys, and today we are going to be continuing learning about Git remotes. Hopefully, we're going to finish the remote section and move on to branching. Um, yeah, dude, this is actually taking longer than I thought it would, but I'm not complaining too much about it because I kind of need to solidify this let's call it foundational knowledge before I start doing Git stuff more often. Because once I start doing it, I'm gonna be using it like heavily, big time. There's so many different repos that I've wanted to make and upload to GitHub, and also actively maintain them on GitHub, but through my terminal based workflow. um and I haven't gotten around to doing any of that because I didn't have, or at least I wasn't comfortable with the foundational knowledge that I had, and I felt like I needed to build up on it. Um hold on, what are we looking at here? Oh, okay. Yeah, I wasn't entirely comfortable with the the foundational knowledge that I did have, and I felt like um I needed to build up on it, and then after that, I'm gonna continue doing all of the Git stuff that I want to do. Okay, all right, now, give me a second. There's a couple of things I need to just close. Undoing things, check out. We're done with revert, and yeah, I think we're good. Okay, so let me bring that back. Okay, all right. So, um, yeah, dude. I guess instead of beginning with a yap sesh, I guess we'll just jump right into it. We'll just continue learning about Git Remote, or remotes, I guess I should say. Yeah, yeah. So, yesterday we had stopped at this point, which was fetching and pulling from your remotes. As you just saw, to get data from your remote projects, you can run git fetch remote. Did we see that? Git fetch pb. I don't think I did that. Okay, okay, let's read from here. Adding remote repositories. We've mentioned and given some demonstrations of how the git clone command implicitly adds the origin remote for you. Okay. Um, here's how to add a new remote explicitly. To add a new remote git repo as a short name, you can reference. Hold on, my God. To add a new remote git repo as a short name, you can reference easily run so and so so and so. Okay, all right. Did I do this? I don't remember if I did this. Um, Yesterday we were doing stuff here. This is tick git. Um, oh yeah, I did. Okay, looking up in the scroll back, I can see, or looking at the previous commands, basically, I can see that we did git remote add pb. So pb is our short name, and then the URL is the repo itself. Okay, now you can use the string pb on the command line instead of the whole URL. For example, if you want to fetch all the information that Paul has, but that you don't have in your repository, you can run git fetch pb. Okay. Where was I? You can run git fetch pb. I think I did this as well. So what did it fetch exactly? Okay, Paul's master branch is now accessible locally as pb master. You can merge it into one of your branches, or you can check out a local branch at that point if you want to inspect it. We'll go over what branches are and how to use them in much more detail in Git branching. Okay, all right. Okay, fetching and pulling from your remotes. As you just saw, to get data from your remote projects, you can run git fetch so and so. The command goes out to that remote project and pulls down all the data that, wait, the command goes out to the remote project and pulls down all the data that the remote project, all the data from that, all the data from that remote project that you don't have yet. Sorry, zoned out. Okay. The command goes out to that remote project and pulls down all the data from that remote project that you don't have yet. After you do this, you should have references to all the branches from that remote, which you can merge in or inspect at any time. If you clone a repo, the command automatically adds that remote repository under the name origin. So git fetch origin fetches any new work that that has been pushed to that server since you cloned or last fetched from. Since you last cloned it. Okay, since you last cloned it. It's important to note that the git fetch command only downloads the data to your local repository. It doesn't automatically merge it with any of your work or modify what you're currently working on. You have to merge it manually into your work when you're ready. If your current branch is set up to track a remote branch, see the next section and Git branching for more information. You can use the git pull command to automatically fetch and then merge that remote branch into your current branch. This may be an easier or more accessible. Where did I read accessible? Okay, anyways, this may be more easier or more comfortable. This may be an easier or more comfortable workflow for you. And by default, the git clone command automatically sets up your local master branch to track the remote master branch, or whatever the default branch is called, on the server you cloned from. Okay, running git pull generally fetches data from the server you originally cloned from and automatically tries to merge it into the code you're currently working on. A note from git so and so onwards, git pull will give a warning if the pull.rebase variable is not set. Git will keep warning you until you set the variable. If you want the default behavior, I guess I'll look into this later on. Pushing to your remotes. I haven't fully understood the like everything surrounding this because what I'm getting is okay, fetch is gonna pull what branches? Let me have an active conversation open with Gemini. By the way, they changed the layout of they changed the UI in general, um, which is great. And additionally, now there's other options other than, so previously they had fast thinking, and I forgot what the other one was called. Now they have 3.1 flash lite, 3.1 flash, 3.1 pro, and then there's a separate thing for thinking level where you can set it to standard or extended. Extended would be for problem solving related stuff. Okay, all right. Hey, I'm learning Git. Help me understand what exactly um, happens when I add a remote, and what exactly happens when I fetch. Um, is adding a remote adding a branch or the whole repo? And when I do fetch, is it fetching a branch or the whole repo? Okay, it's totally normal to feel a bit confused by this when you're starting out. Git's terminology can make it feel like there's some mysterious magic happening under the hood, but it's actually much simpler than it looks. Let's break down exactly what happens in both scenarios. What happens when you add a remote? The short answer, adding a remote does not download any branches, code, or the repo. It is literally just saving a bookmark or a shortcut. When you run a command like git remote add origin and then whatever link, you are simply telling Git, hey, see this long URL? I want you to remember I want you to remember it. And from now on, whenever I type the nickname origin, I want you to use this URL. Is it adding a branch or the whole repo? Neither. It doesn't touch the internet and it doesn't download a single file. It just edits a tiny text file inside your local hidden git config directory to save to the nickname to URL mapping. Okay. What happens when you fetch? The short answer, fetching downloads the whole repository's history, all branches and commits from the remote, but it does not touch your personal working files. When you run git fetch origin, okay, so adding the remote adds a link and gives that link a nickname so we can then reference that link, or Git can then reference that link whenever we use the nickname. Now, the nickname is used in a couple of places, one of them being git fetch. And so it is the link that we gave was for the entire repo. It wasn't for like, it wasn't pointing to a specific branch. It was pointing to the entire repo, right? Even in git fetch, we are using this nickname, meaning we are pointing to the entire repo. Again, no specific branch. Give me a second. Um, okay. All right. You know what I'll do? So I've paused the RTMP feed. I've actually stopped the RTMP feed. I'm gonna make the browser window bigger, and now I'll continue reading from here. I just want to give my fans a little rest. I need to do something about this, dude. Like each time I stream now, I'm getting this, you know, fan noise kind of thing happening, and it's happening because of heat, because you know the system is getting overloaded with whatever is going on. Um, yeah, I need to find a better way to go about this. I need to, dude. I should definitely continue studying about Western because I haven't finished learning about how to do multiplexing in Western, and further from that, I also haven't explored the concept of SSH domains in Western. Um, Once I set that up, then I'll be able to very easily set up my Tmux workflow there, or at the very least, I can begin setting up my Tmux workflow there. Moving the entire Tmux thing over there, that'll be once I've explored this thing a lot more, and once I'm, very comfortable with the with the multiplexing and the SSH part of this of Western. I mean, once I'm comfortable with all of those features, then I can try setting up my entire workflow there. So, sorry, setting up the entire like Tmux workflow there. The next thing I'm gonna have to do then, my next challenge is gonna be getting a good frame rate when my VTuber application is running and the browser is running, and both are being captured, by the way. And additionally, I have I have Western running, showing this, what do you call it? Additionally, I have Western running, showing this matrix rain and the Tmux windows and stuff like that. I'll have to see how I can go about running this setup. At the very least, I could just open up the Western browser, sorry, the Western terminal, and set up, this exactly how I have the RTMP feed. No, how I have stuff set up that you're seeing through the RTMP feed. Basically, it's the matrix rain and the two Tmux windows. At the very least, I can set this up in Western and try to run it. So then I'll be capturing that Western window, which is still using Tmux, but you know, um, there's an advantage of that because running Tmux makes it so I'm able to do what I'm doing here. Um, like I have two panes, and in each of the panes there's a separate Tmux session running. Within that Tmux session, within each Tmux session there's multiple Tmux windows, and I'm able to like move in between them. Doing that within Western might get a little bit complicated if I try to set it up in the way that I've set this up. So I have to see how to go about doing that. But the good news is that at the very least, this is possible. At the very least, I'm able to, replicate this setup there. So then I'll be capturing the Western window, my VTuber application, and the browser. It'll be these three windows that need to be captured, and um, we won't need to have what do you call it? Yeah, we won't need to have an RTMP feed then, so it's going to be a lot more snappy. I don't know how I'm going to set up the webcam feed though. I might still need I might still need the RTMP feed for the webcam. So that might be an issue. I mean, there are things that I can do in order to solve that problem, but I don't know. I don't know. Anyways, okay, enough brainstorming. Let's continue reading. So, When you run git fetch origin, I'm reading from the Gemini conversation right now. Git looks up the URL for origin, goes out to the internet, and downloads all the commits, files, and branches that exist on GitHub that you don't have yet. However, Git keeps this hidden away in a safe, isolated zone. It updates when what? It updates what are called remote tracking branches, which look like origin slash main or origin slash feature branch. Is it fetching a branch or the whole repo? By default, git fetch updates tracking info for the whole repo, so meaning all branches. Why can't you see the changes yet? Because fetching is a safe operation. It updates Git's internal map of what the remote server looks like, but it never merges those changes um, into your local files. Your current your current workspace remains completely untouched until you explicitly run a command like git merge. Think of it like a package delivery. Git remote add, you write down the warehouse's shipping address in your address book and label it warehouse A. No packages have moved yet. Git fetch, the delivery truck brings all the packages from warehouse A and drops them off on your front porch. Your house, your local branch, hasn't changed inside, but the packages are sitting there ready for you to open. Git merge, you bring the packages inside your house and unpack them. Combining fetch plus merge is what git pull does. Um, yeah, that's it. Okay. Want to see the difference between git fetch and git pull? No. Um, can you explain the remote tracking thing again, or thing in more detail? So I'm asking this because I remember having this conversation with Gemini. This was I think a conversation that I had with Gemini CLI maybe when I was trying to understand what exactly happens when, because I remember this whole thing. I just wanted to refresh my knowledge of, like, fetch and pull and stuff. And I remember having all of these conversations, having and Gemini telling me that, yeah, when you just fetch, it pulls the information, but it stores it in a separate place. I couldn't remember what that place was called, but remote tracking, that's something similar. um, so in this case, it's a remote tracking branch, and it stores the information there. Later on, you can decide to merge if you want to. I need to see if there's a way for me to diff the branches, the local branch versus the remote branch, or versus the remote tracking branch. I want to see if there's a way to diff it. Um, Additionally, I want to see if there's a way to um, what was I saying? Additionally, I want to see if there's a way to look at both the branches side by side or diff both the branches in Git UI. One way to do it would be, it's not exactly diffing, but like, if possible, maybe I could open up two instances of Git UI and, have one pointing to one branch and the other pointing to another branch. I could do that. I don't know how well that would work out, but we can try that out. We can, like, I'll have to see how to go about that. Okay. Um. Gemini answered the question. This is usually the exact moment where Git starts clicking for people. What just happened? Oh, that's what happened. Okay. Okay. Yeah. Okay. This is usually the exact moment where Git starts clicking for people. Remote tracking branches are the quote unquote secret sauce that allows Git to work so incredibly fast offline. To understand them, you have to realize that your local Git repository actually keeps two completely separate copies of the remote repository's branches inside its head. The three states of a branch. Okay, when you are working with a remote like GitHub, you aren't just dealing with quote unquote my code and quote unquote their code. You are dealing with three distinct types of branches on your machine. One, your local branch, um, which is where you actually work, write code, and make commits. It's your personal sandbox. Two, um, the true remote branch, example, main on GitHub. This lives entirely on GitHub's servers out on the internet. And three, the remote tracking branch, example, origin slash main. This is the local read only copy or blueprint of the true remote branch stored right inside your computer's .git folder. Okay, how origin slash main acts as a cache. Think of a remote tracking branch, which is origin slash main, like a downloaded snapshot or a browser cache of what GitHub looked like the last time you checked. Because it lives on your hard drive, Git doesn't need to ask the internet every time you want to compare your code. Scenario A, a working offline. What? Scenario A, working offline, no fetch. If your coworker pushes five new commits to GitHub, your local main and your local origin slash main don't know about it. If you type git status, Git looks at your local main and compares it to your local snapshot. Okay, I feel like this is important to keep in mind. This is important to understand. So if you use git status, then Git looks at your local main and compares it to your local snapshot, which is origin slash main. Because both match on your computer, Git happily says your branch is up to date with origin slash main. Even though it's technically lying, it just doesn't know any better yet because it hasn't talked to the internet. Then scenario B, you run git fetch. When you run git fetch origin, okay, origin is the remote. It's not the branch. I just needed to remind myself that Git reaches out to Git reaches out to GitHub, sees those five new commits and downloads them. But instead of forcing those five commits into your personal working branch, which is main, Git moves the origin slash main pointer forward to point at the newest commit. Now, when you type git status, Git compares your local main to the newly updated snapshot origin slash main and says, your branch is behind origin slash main by five commits and can be fast forwarded. What do they actually look like? Okay, let's test this out. If you want to see this in action on your terminal right now, try running this command: git branch a. Give me a second. Uh, Hold on. I need to open up my phone. Sorry, open up my what do you call it? My chat on my phone. Okay, all right. Um, so, just so you guys can also see this now, I will shrink it back down, bring it here. Okay, all right. Next, I need to restart the RTMP feed. Okay, we should be doing better now. All right. So, um, Git branch A. The A stands for all. You will see a list that looks something like this. Main, remote, so and so. Okay, let's do that. Git branch A. Oh, damn. Okay. It is so long that it put the thing in a pager instead. Though to be fair, everything else is basically just remotes. Um, there's only one branch locally, and that's master. Though, okay, so what we have here is remote tracking. Oh, wait. So a remote tracking branch will only exist if you have remote in the first place, if you have the thing added as a remote. I need to confirm that because it does say remote slash origin. Origin is the remote. Origin is the nickname of the remote. All of this is pointing towards origin. Where's the PB thing that I added? Where's that gone? Oh, it's down here. PB is another what do you call it? PB is another remote that we added. Actually, if I do git remote, does it display? Yeah, it does. Okay. Uh, what all can I see here? Git remote v list existing remotes with their names and URLs. Okay, so we can do v for verbose. Show remote name. Show information about a remote. Git remote show remote name. Okay. Add a remote. All right. Change the URL. Okay. Get the URL. Okay. Remove a remote and then rename a remote. Okay. Let's try a couple of these. Git show PB. Is that it? No. Git remote. Remove remote. Remote show PB. Okay. Let's do git remote v. Interesting. So it has two separate things, one for fetching and one for pushing. Okay. All right. Okay. All right. Continuing reading here. Main in green, usually with an asterisk, is your live workspace. Actually, yeah, that was we did have that, didn't we? Uh, yeah. It's not green in my case, but like I get the point. The ones starting with remote slash origin are your remote tracking branches. You can check them out. You can check them out to look at them, but you can't commit directly to them. They only move when git fetch tells them to. Okay, what if I do git fetch right now? Does it just fetch everything? Oh, it did. Yeah, it fetched for origin. And apparently it fetched a tag. It fetches branches and tags. That's interesting. Okay, all right. What about fetch PB? Apparently there's nothing. I could do fetch origin. There's nothing because we just fetched information. So this fetch should also not do anything. Okay, all right. Okay, now, what was my next question? There was something I was going to ask regarding remote tracking branch. Oh, yeah. So the tracking, um, the the remote tracking branches only exist because we added a remote, and that remote has branches. We added a remote fetched from that remote, and that remote has branches. You hit the nail right on the head. That is exactly how it works. To map out your exact logic chain, a remote tracking branch is born and updated through this exact sequence. First, you add a remote. So Git learns the URL. At this moment, zero remote tracking branches exist. You run git fetch. Git goes to that URL and asks, what branches do you have right now? Okay. Um, what branches do you have right now? And then Git builds the tracking branches. For every branch, GitHub says it has, example main, feature XYZ, and so on. Git creates a matching local read-only bookmark on your machine named origin/main and origin/feature XYZ. All right, okay. If that remote server is completely empty and has zero branches, your fetch won't create any remote tracking branches either. They are purely a local reflection of whatever existed on the remote machine the exact second you hit enter on git fetch. You officially mastered one of the trickiest conceptual hurdles in Git. Okay, great. Um, right. Okay, I guess we can continue reading then. So, where were we? Give me a second. Okay. Oh, let's also refresh the feed. I don't know if it's like out of sync or something. The browser seems to have vanished for some reason. Oh, okay. All right. Browser's back. All right. Okay. Where was I? Yeah, okay. Pushing to your remotes. Hold on. I have another question. Hey, so I'm wondering, um, since I'm able to create a bare repo on my local machine or a machine on the network, um, if, assuming the local, hold on, assuming the bare repo is on the same machine where I have a clone, would would I be able to push and pull without using SSH? See, the reason I'm asking this question is because running it over the Git protocol, like if we are doing it across the network, it's going to be running over the Git protocol. We don't have to do any of that manually. It like Git handles all of that stuff. However, that is done over SSH, and that's fine. I do have SSH running on one of these machines, and that is the whole reason why I'm able to, do tmux stuff remotely from another machine and all of that. I have SSH set up. But I do remember reading that if it is if you are pointing to a bare repo that is on the same machine, then internally Git just changes the way that it routes that command. So it doesn't then do a sort of network request. It doesn't do a sort of SSH request. It just does a local file request. But I wasn't entirely sure if it's still somehow going to use SSH. But let's see what Gemini is saying. Yes, absolutely. You can push and pull without SSH, and it is incredibly fast because Git doesn't have to go through a network protocol. Okay, that's good to know. When your remote repo lives on the same machine or on a locally mounted network drive, Git uses what's called the local protocol instead of an SSH. That I believe that was mentioned somewhere here. Hold on. Wait, I'm gonna open up the page about Git on a server. The protocols, getting so and so, so and so, so and so, setting up the server, Git daemon. I remember reading through all of this to explore my options, and it took me a bit to understand how each of these protocols was working. It took some time for the dots to connect. It took me a bit to understand that the Git protocol itself exists, and if I have SSH set up, I don't need to worry about anything. I can just get Git to use SSH. Git is going to use SSH. If I'm if I'm doing it solely through Git's commands, it's going to use SSH. And in my case, I don't have SSH private keys set up. So each time that I have to do an SSH related command, I have to enter the password for the username for the user login, and I'm okay with that. I don't mind having to enter that. I just haven't taken the time to set up that SSH private key workflow. So each time I want to do something SSH related, I just have to enter the password, and that's okay. I'm fine with that. Okay, now the great thing here is that because I'm doing this locally. Actually, for GitHub, it might be a little bit complicated. Yeah, for GitHub, it's going to be actually okay. For GitHub, there is a different workflow. I just remembered this. Yes, GitHub also has a way of saving your credentials. You only have to enter it once, and then it gets saved by GitHub. And not GitHub. I mean the GitHub CLI. It gets saved by the CLI somewhere on your system, and further from that point, it just uses those credentials. It doesn't ask you to keep entering the credentials again and again. I don't remember if I had to log in or if I had to copy an API key from somewhere, or like I don't remember what the situation was, what the workflow was. But once I did that, then I was able to very easily, pull and push and stuff like that. I am gonna need to look into that though, because I do plan on like my workflow, my setup is gonna be basically that I have two central repos. One central repo lives on my local machine, and the other lives on GitHub, and both are the exact same. The only difference is that one is on my local machine and the other is on GitHub. So that's basically the only difference between them, because I want to keep one on GitHub as well as keep one on my local machine, and that way if at some point in time either one of them goes down for whatever reason, then I have the other copy with me and I can instantly make another thing. At some point in time, I'm gonna need to start building like a proper home lab. I mean, I kind of already have a home lab set up. It's just that it's a little different. What I have is a couple of machines that I have a couple of old computers that I've put together to not even put together. They're all on the same network. And thanks to tools like Tmux, I'm able to I'm able to work in between them. Thanks to SSH as well, I'm able to work in between them. And also thanks to my terminal based workflow, I'm able to work, in between them. Um, But yeah, at some point I do want to set up my own home lab, because with a home lab you have like a different kind of thing going on in terms of both hardware and software. um at least, the infrastructure, I should say, like the software that everything else is going to be running on. So like, to give you an example, how it would work is you have Proxmox installed. I don't even remember where you would install Proxmox, but then within Proxmox you can either have um, a virtual machine running, or you can have a Linux container running, and you can choose which hardware to run this on. So you can have multiple hardware attached to your setup. So let's say you have, I don't know, a couple of Raspberry Pis. So these are multiple separate computers, right? They can all be attached via the network, via like Ethernet to your setup, and you would be controlling this Proxmox. You'd be controlling Proxmox through another machine, either through the CLI or through the web UI that they provide, and that'll be your control panel, essentially. And there's a lot of interesting stuff that you can do with that, because you can then, I mean, I could technically do that now as well. It's not like I absolutely need Proxmox and, I need to run LXCs and stuff like that. LXC is Linux container. Um, However, if I did do that, I think I would be able to squeeze a lot more out of the hardware, because in that case, at least from my understanding, they're all sharing the same kernel. Um, I believe so. I believe so. They're all sharing the same kernel. Um, I can't remember the specifics surrounding like when you attach multiple devices, but apparently Proxmox does handle that as well. There's just a specific way to go about doing that. But um, yeah, you have these multiple Linux containers where you can run an entire OS within which you're running, multiple programs and stuff. And each of these containers, they are all sharing the same kernel. All of that, I believe, gets managed by Proxmox. So like the setup, when you have like a Proxmox kind of setup, it's a lot different than, when you have a couple of computers with um, Ubuntu installed on all of them. That being said, I don't think there's anything stopping me really from having that very bare bones Proxmox LXC setup, even with these computers that I currently have. I could repurpose any one of these and turn it into exactly that. And again, because of my terminal based workflow, I would then be able to SSH into the machine from any other machine, and set up a bunch of containers. Within the containers, I can have a bunch of things running. Most likely, I'm only going to have one Linux container running. I don't think I'm going to have multiple, but I'll see. I'll see. Depending on what the situation is like. I also feel like I should really learn how to use Docker, um, because I'm seeing more and more use cases for it. I mean, it's been around for a while now. It's just that I haven't directly had any use cases for it. Um, so I didn't really bother looking into it too much. But then now I'm actually seeing use cases, because there are a bunch of programs, a bunch of open source like frameworks and stuff. OpenClaw is a very good example. OpenClaw provides you with a Docker image that you can use. And using a Docker image is, especially with like very sophisticated software, using a Docker image is a lot better than installing all the dependencies that the package has, because you might create a mess of dependencies on your own machine for the sake of running that one program. Meanwhile, you could have kept everything simple and isolated and clean just by running a Docker image instead. So I need to learn about Docker. Um, And who knows, maybe it might be beneficial for other stuff that I'm working on as well. But that being said, now that I know, oh yeah, I was gonna look at this thing. So Git on the server, Git protocols, or the protocols. At this point, you should be able to do most of the day-to-day tasks for which you'll be using Git. However, in order to do any collaboration in Git, okay, here's the thing, right? Um, they they taught us about working with remotes here, which is kind of interesting. But like up until this point, I don't think they ever mentioned running or even creating your own like bare repo, your own central repo. The examples that they're giving here are for stuff that's hosted online. So in this case, GitHub, for example. So for the sake of teaching about remotes, they are teaching us, okay, you can create a new remote that points to a certain repo, and then you can, dude, I wonder what would happen if I just created a bare, not okay, I shouldn't say bare. I shouldn't even say bare bones. I'm used to saying bare and bare bones, but like in this case, bare actually means something in Git. So I'm not going to say bare, just an empty repository with a working tree. So it's not a bare repo. Um, let's say I created a working working empty. I created just an empty repository. Maybe I put in like two or three text files and added some garbage text in there. Fine. I have a repo. I have a couple of files in there. Great. What happens if I add a remote to a repo? We can, dude, we can do that right now. Hold on. We can test this out. What is it? SCH. Okay. I don't know how to pronounce this person's name and I don't want to butcher it, but I'm gonna test this out. Okay. We're gonna create some repo o3. Okay. And then we're gonna cd into some repo o3, git init. Okay, let's actually, I can do it in this way. Echo ABC into some o1.txt, echo 123 into some o2.txt, echo this is a sentence into some o3.txt. This is our Git repo, right? We have our repo here. Let's also make a commit. Done. Great. Awesome. Now, um, we will add, so git remote add, let's do origin, git remote add origin, HTTPS, GitHub, GitHub, what? GitHub, github.com slash, assuming person's name, I don't know, tick git. Now I need to get this right because this doesn't reach out to the internet at all, so I'm not going to know if I get it wrong. I think I got it right. I think I got it right. Yeah. Okay, that's done, right? Now let's fetch. Oh God. Okay. Um, it fetched. Okay. Damn. Uh, right. Okay, so open up Git UI. Let's look at branches. Under remote, we have all of these. Okay, where do um where do the remotes get stored? There's nothing in branches. Hooks, info, logs. Oh, okay. It's here. I still haven't understood this dependabot, and there's a cargo thing in here. But I'll look at that later. Um, So these are, this is all the data that they have? No, they do have some data. Seems to just be zero though. Okay, let's look at master. So we're gonna copy this. I need a thing here. Let's yeah, let's hijack this one temporarily. Oh, oh, okay. All right. I am glad that I did that setting previously. Anyways, okay. All right. So now at this point, so have we covered um merging, or is that being covered here? Git remote show. Git remote show origin. Let's take a look at what the thing says here. Git remote show origin. Okay. All right. What was I gonna do? Oh yeah. So the next thing to do is to merge it, right? Um, they've given an option for push, or they have a section covering push. Did they do a merge thing here? They're saying that you can do pull. Pull is fetch plus merge. What if I just wanted to hold up? Man git merge. Join two or more development histories together. Okay, all right. Um, assume the following history exists and the current branch is master. Then git merge topic will replay the changes made on the topic branch since it diverged from master until its current commit. C. Uh, hold on. It says git merge topic will replay the changes made on. So if I wait, if I want to do, wait, don't I need to be checked out on the remote tracking branch? How am I meant to? Wait, I need to look this up. Hey, I'm learning Git. I have a remote um, linking to a GitHub repo added to a local repo of mine. I've Git fetched and a bunch of branches are being tracked right now. Or I should say, and now I have a bunch of remote tracking branches. Um, how exactly am I supposed to merge master from the remote tracking branch to my local master branch? Okay, it's awesome that you're learning Git. Getting your head around remote tracking branches is one of the trickiest parts when starting out. But you have already done the heavy lifting by running git fetch. Right now, your local repo knows exactly what is happening on GitHub, but it hasn't actually touched your local working files yet. Here is how you bring those changes from the remote tracking branch into your local master branch. Okay, switch to your local master branch. Okay, before you can merge anything into your local master, you need to be standing on it. Yeah. All right. Let's do git log one line. We are currently on master. Okay. What if I just did git branch? We are currently on master. Okay. All right. Merge the remote tracking branch. When you ran git fetch, git created an updated Git created or updated a branch named origin/master. This is your remote tracking branch, a snapshot of what master looked like on the GitHub the moment you fetched. Now tell Git to merge that snapshot into your current local branch. All right. Let's do Git merge origin/master. It says refusing to merge unrelated histories. Okay, so I guess this is kind of answering my question of what if I added a remote for a completely unrelated repository and just tried to, pull the changes from a completely different repository into this one. So now I'm going to explain this to Gemini and let Gemini explain to me what exactly happened. Okay, so Gemini is saying Gemini is assuming that my thing worked, or well, Gemini is assuming that the command worked, and it's explaining to me what just happened. Depending on whether you have made any new commits on your local machine, one of the two things will occur. Fast forward merge. If you haven't made any new local commits, Git will simply slide your local master pointer forward to match origin/master. It's instant and clean. Or merge commit. If you have made local commits while someone else pushed to GitHub, Git will combine the changes and ask you to save a merge commit message. Pro tip, in the future, you can combine git fetch and git merge into a single command by running git pull origin master. Okay, it does exactly what you just did manually in one step. Okay, so here's the thing. I purposely set up a simple empty repo, added 3 files to it, put some garbage text in those files, and then added a remote linking to tick git on GitHub. I wanted to see if that would overwrite my entire repo. Now that I'm thinking about it, like now that it failed, and I'm thinking about like how dangerous this could be if someone accidentally did this. I did it on purpose, but like how dangerous it could be if someone actually did it and it overwrites overwrote their entire, current branch. Like that could be a mess. Okay. If that would overwrite my entire repo, or current branch. Well, didn't work. Um, can you explain in detail what's going on here? It's a good thing that it didn't work because it makes it so fatal errors can't happen, such as overwriting an entire branch with a branch from an unrelated repo. But I want to understand. Okay, you've hit on one of Git's core design principles. Git is fiercely protective of your work. It is built specifically to prevent you from accidentally vaporizing your local files just because you link to a new remote. When you stumbled, what you stumbled into is a built-in safety guardrail. Here's the exact step-by-step breakdown of why Git refused to overwrite your repo and what is actually happening under the hood. Git fetches, but it doesn't touch your files. When you ran git fetch, Git went to GitHub, looked at the tick Git repository, and downloaded its entire history. However, git fetch never alters your working directory, the files you see on your computer or your local branches. It simply copies the remote branches uh, into hidden tracking branches like origin/master or origin/main. At this point, your three garbage text files were completely safe because fetching is 100% read-only operation for your local workspace. The concept of unrelated histories. The real magic happened when you tried to merge either via git merge or git pull. It looked at your local repository and the tick Git repository and compared their family trees. Your local repo, sorry, your local repo has a history that started on your computer with your three files. It has a specific initial commit ID. The tick Git repo has a completely separate history that started years ago on someone else's computer with a completely different initial commit ID. Because these two repositories do not share a common ancestor commit, Git views them as entirely different universes. If you tried to merge them, Git likely threw this exact error at you, fatal, refusing to merge unrelated histories. Yep. Okay. The safety rule, Git assumes that if two branches don't share a common ancestor, merging them is almost certainly a mistake that would cause chaos. So it locks down and refuses to do it. Why it wouldn't just overwrite everything anyway? Even if you force them to merge, Git's default behavior is to combine histories, not replace them. Git If Git did allow the merge, it would take the files from tickgit and try to add them to your folder alongside the three garbage text files. It wouldn't delete your files unless there was a specific conflict, like if your file was named readme.md and tickgit also has readme.md. How to actually force it, the dangerous command. Oh shit, okay, we can do that. You are completely right that this prevents fatal errors, but Git always gives you a way to override its safety features if you tell it, I know what I'm doing. Okay? If you actually wanted to force Git to smash these two unrelated repositories together, you would have to explicitly pass a special flag. Okay, if you ran that, Git Git would drop its guard, um, blend the two histories together, and you'd end up with a giant mashup of the tick-git source code and your local files. Want to try another experiment? Since you are testing Git's boundaries, do you want to see how to completely override your local branch with a remote one on purpose using Git reset? No. You know what? I have another question. So first of all, good to know that I can do it. Um, what was it? Allow unrelated histories. Enter a commit message. Okay, okay. This is a forced merge of tick gits master branch with some repo o3's uh, master branch. Save, quit. Okay, that's crazy. Wait, hold on. Now in the log, we have a lot more commits. Yeah, okay. Yeah, I forgot. Merging branches does also merge commits. I completely forgot about that. My mind was only focusing on files, which yeah, that got affected as well. But yeah, my mind was mainly focusing on the files. I wasn't even thinking about the I guess I would have been thinking about this if we were in the branches section. Uh I I guess at this point, so we'll not look at the pushing section. There's renaming and removing remotes as well. That's fine. We won't look into that. What more is there here? There's tagging. Tagging is important. We did need to look into tags. So there's creating tags, annotated tags, lightweight tags. Where are we using the tags? Um, okay. We're gonna look into tagging. For now though, I think I can just delete this. What about here? Let's go. Actually, um, yeah, let's do that. And then here, yeah, let's also do that. And let's remove some repo o3. Okay. I was having another conversation with Gemini about like doing the local bear repo thing. I had a question regarding that. I forgot what the question was. But yeah, we were also looking at this thing, right? Protocols, local protocol. The most basic, the most basic, I guess this is where it gets explained. Um, Here, the protocols. Git can use four distinct protocols to transfer data: local, HTTP, SSH, and Git. Wait, was I wrong to assume that using the Git protocol it would be using SSH? I thought it was running Git on top of SSH. Wait, we'll see. We'll see. Um, Here we'll discuss what they are and in what basic circumstances you would want or not want to use them. Local protocol. The most basic is the local protocol, in which the remote repository is another directory on the same host. This is often used if everyone on your team has access to a shared file system, such as an NFS mount. I just remembered the question that I had um, regarding a bare remote repo. Hey, I'm learning Git. I'm um, I'm currently wait. My plan is to set up um, a, a central repo for my project. Um, Wait, my plan is to set up a repo for my project. However, it won't just be one repo. Um, I want to set up a central repo, bracket bare repo, and um, a clone, or, well, let's say a working copy, which is where I will be staging and committing changes. The idea is that the central repo is where I pull from and push to. What I'm wondering is, how do I get this setup started to begin with? Because a bare repo is empty when you first create it. BTW, both repos are on the same machine. Okay, setting up a central bare repo and a local working copy on the exact same machine is a fantastic way to learn how Git functions under the hood. It perfectly mimics how platforms like GitHub or GitLab work, just entirely within your own local file system. Because a bare repository doesn't have a working tree, that is the actual files you can edit, you can't just create files inside it directly. Instead, you initialize the bare repo first, then connect your working project to it. Here's the exact order of operations to get this running seamlessly. The setup process. Under the hood, a bare repository only contains the version control data, that is the contents of what is normally hidden inside a Git folder. Because it doesn't have to manage active file edits or conflicts, it is perfectly optimized to receive your Git push commands without ever getting confused. Wait, because it doesn't have to manage active file edits or conflicts, it is perfectly optimized to receive your git push commands without ever getting confused. Okay, from this point on, you can treat your My Working Project folder exactly as you would if you were working with GitHub. You can make changes, stage them, commit them, and then use git push origin main to sync them to your local central repository. Creating, wait, okay, hold on. What does that setup look like? Okay, so the first step is create the central bare repo. Open your terminal, navigate to where you want your central server to live, and initialize it with the bare flag. All right, great. Note, ending the folder name with .git as a standard convention for bare repositories. Now navigate to the separate folder where you actually plan to write your code and build your project. Initialize this one normally. Okay. While inside your My Working Project folder, you need to tell Git where the central. Okay, what's the other one called? What's the bare one called? It's just called my. Oh, so my project.git and then my working project. These are two separate directories. Yeah, you need to tell Git where the quote unquote central repository is. Instead of a URL, you will point it directly to the local folder path of your bare repo. Okay, so remote add so and so and done. Okay, all right. Because the bare repo is completely, hold on. Because the bare repo is completely empty, it doesn't have a default branch yet. You need to create your first file and commit it in your working directory first. Oh, okay. So make a commit. Finally, push your initial commit up to the central bare repo. It establishes your main branch, usually main or master, on the central repo. Then git push u origin main. So the u flag tells Git to remember this connection. So the next time you can just type git push or git pull. Oh, okay, okay. Reason the user is in learning mode. Oh, this response is all fucked up, dude. The formatting in this response, it's kind of like all over the place. You guys can't see it though because it's not being shown on stream, but yeah. Wait, so this bare repo will just accept any branch that anything pushes to it? By default, yes. Git is designed to be highly trusting out of the box. If you or another working directory on your, working repository on your machine creates a brand new branch and runs git push so and so, the bare repository will happily accept it, create that branch on its end, and store the history. However, it won't just let anything happen blindly. Git has a built-in protective barrier for its history, the fast forward rule. While the bare repo accepts new branches, it'll fiercely protect existing branches from being accidentally overwritten. If you try to push changes to a branch, but your working copy is out of date, because changes were pushed from somewhere else first, the bare repo will reject your push with a rejected non-fast forward error. It forces you to git pull and resolve any conflicts locally because it allows you to update before it allows you to update the central history. Okay, let's say I have two projects, um, proj O1 and proj O2 with completely different sets of files and directories in each, and I have one um, bare repo. Let's say I pushed branch O1 from proj O1 to the bare repo, but then I pushed branch O2 from proj O2 also to the bare repo. These are two different working trees. So what's happening in that case? If you do this, Git won't crash or throw an error, but you will create a multi-headed monster of a repository. To understand what's happening, you have to look under the hood at how Git actually stores data. Git doesn't care about quote unquote projects, it only cares about commits and independent history lines. Here is exactly what is happening inside that single bare repository when you do this. You create two orphaned root histories. Normally, every branch in a Git repository can be traced back to a single shared initial commit, like the root of a tree. By pushing two completely different projects into the same bare repo on different branches, you are creating two independent trees in the same forest. Branch O1 has its own root commit the day you started Proj O1. Branch O2 has a completely distinct root commit the day you started Proj O2. They share absolutely zero common history. In Git terminology, these are called unrelated histories. How Git stores the files. Inside the bare repo's objects directory, Git compresses and stores every single file from both projects. Because Proj01 and Proj02 have completely different files, Git just stores them all side by side in its database. When you look at branch O1, Git reads the database and shows you only Proj01 files. When you switch or look at branch O2, Git reads the database and shows you only Proj O2 files. They do not overwrite or mix with each other because they live on completely isolated branches. Why this can get messy fast? While Git is technically capable of handling this, it can lead to some major headaches down the road. The Git pull trap. Imagine you are inside your local proj01 working directory and you accidentally type git pull origin branch O2. Git will look at branch O2, see that it shares no common history with your current branch, and completely refuse to merge them. It'll throw a fatal error, refusing to merge unrelated histories. Note, you can technically force it. Yeah, okay, okay. Bloated repository size. Yeah, that makes sense. Yeah, because you have like two separate projects in one bare repo. The verdict. What you have created is a valid Git repository, but it is generally considered a bad practice unless you are intentionally doing it for an advanced monorepo setup. Okay, so that's how you set up monorepos? Because I've seen like in select few projects the concept of monorepos. I never really questioned how exactly they work on those because I was just assuming that they merge all the projects into one and then that's that. But like, I think it might be a little more complicated than just that. Okay, okay. You know what? That's great. So I think what I'll do is, in order to understand this better, I am going to set up a local bare repo, and I'm going to start doing the pulling and pushing. I don't think I'm going to use pull directly. I'll stick to the fetch and merge for now. Later on, I can look into. Actually, I need to also see how to do it through what do you call it? How to do it through Git UI. I need to look into that as well. But yeah, I do want to set up the bare repo and set up remotes for like a local project. I need to set this thing up because this is what I'm going to be doing later on. The whole idea is to have a central repo for each of the projects that I'm working on. There's going to be the working copy that I'm actually working on, and then there's going to be a central repo for that one project. And just like that, for every project, I'll have a working copy and the central repo. And the central repo is going to be a remote. And additionally, I'm also going to have GitHub as a remote. I'm going to have to explore that workflow as well at some point. But for now, I want to set up the local repo and play around with that. We're probably going to be doing that in the next stream. Uh, Most likely, most of the next stream is going to be that. We I might finish reading this off stream, the protocols thing, and tagging. I might probably also finish tagging off stream itself. We do need to get into branching, and it's a good thing that we're doing the bare repos thing as well, because branches, um, the topic of branches and remotes, they kind of like connect together, because you have this thing where you push branches. You don't push like the entire repo. You usually push branches. Uh, Also, wait, speaking of pushing branches, I did skip that last part of the thing, right? Pushing is you push a specific branch. I probably shouldn't have skipped this. I just remembered that you usually push a specific branch. With pulling, you merge. Actually, I don't know if pull works in a similar way as well, but like you fetch the entire repo, and then you merge a specific branch, right? So I'm guessing with pull you would have to specify the branch as well. Yeah, yeah. Okay, you know what? That's gonna be it for today's stream. I'm probably not gonna raid anyone. I I'm just gonna continue reading up on this and learning all I need to learn about it. I want to finish the Git stuff quickly, dude, so I can start setting up all these repos that I need to set up, and then we can get back to working on electronic stuff, because we need to make progress with that as well, dude. Holy shit, I haven't I haven't touched that in a bit. Yeah, yeah. So that's gonna be it